In day 91, we have to solve for sec of 2 arctan of 2. So the best way to go about this is to use triangles, and it's important to understand trig first, obviously, and to know that this is going to be a trig ratio, and then that is actually an angle, because it's a parameter for sec, and the inverse of a tan function is the angle. So for example, tan of theta equal to, let's say, some random variable b, then tan of theta is my trig ratio, and so is b, because they're equal. But now theta is the angle, so arctan of b is equal to theta, and that's an angle, and arctan of b is an angle. So the point I'm trying to illustrate here is that this is actually an angle. So we can make 2 arctan of 2 equal to the angle x. And so now, if we're going to solve for tan, then what we have is arctan of 2 equal to x over 2 as an intermediate step, and then we can do tan of x over 2 is equal to 2. So now our new angle becomes x over 2. So we can actually go ahead and draw a triangle with x over 2 as our angle, as one of our angles, and then that can be a 90-degree angle. So that means that this side must be 2 and that must be 1, or not necessarily 2 and 1, but it must be in the proportions of 2 is to 1 because of the trig ratio, where tan is equal to opposite over adjacent. So if this is 2 and this is 1, then this right here must be 2 squared plus 1 squared, which is 5, but the root of it by Pythagoras. Okay, so that's fair enough, but now we need sec of something, sec of x, because sec of x is the same as sec of 2 arctan of 2. So if we're trying to solve for sec of x, then we're also trying to solve for cos of x, because sec of x is 1 over cos of x. But now we have a triangle with x over 2. So here's where an identity comes in handy. So we have an identity, cos of 2 theta equal to 2 cos squared theta minus 1. So now, if we write this rather in terms of x over 2, where we have theta, and in terms of x, where we have 2 theta, then we can take out that 2 theta and put an x, and we can take out that theta and put an x over 2. So now essentially we have another way of writing cos of x that's in a form where we can work with, because we have these ratios here. So our sec of x is now equal to 1 over this. And so now we can solve from the diagram. So cos of x over 2 is going to be adjacent over hypotenuse. So 1 over root of 5 squared, and then we keep this minus 1, and we'll multiply that by 2 again. So now our sec of x is equal to 1 over 2 times by 1 over 5 minus 1, which is just the same as 2 over 5 minus 1, which is just the same as 2 over 5 minus 5 over 5, which is the same as 1 over negative 3 over 5, which is the same as negative 5 over 3. And now I said sec of x was the same as sec of 2 arctan of 2, because we equated x to be 2 arctan of 2. So we get our final solution to be negative 5 over 3.